I am recording. So again, today we talked last time about different ways to use definite integrals to find area between curves, to find volumes of solids of revolution, to find average value. And then we talked about various applications to business of those things. We're going to extend those concepts a little bit today and focus entirely on applications of integration to business. Okay, so I'm going to begin by sharing my browser and just show you where we are. So again, here is the course. We're in week 14, and this is the section we're working on today, integration applications to business. Okay, and I'll be using these optional notes down here in supplementary materials, integration applications to business, if you want to print those off to follow along. Okay, so let me begin by sharing my tablet with you. That usually takes me a minute. Okay, and now let me share that with you. Okay, everybody should be seeing my notes that say section 3.7, integration applications to business. And again, what I do to make these notes is to pretty much excerpt things from your reading, your text. And again, that doesn't mean you shouldn't read the text because I'm not taking everything from it. I'm just trying to hit the highlights. So what we're going to be talking about are specific applications where we're going to deal with area under a curve or the area between curves, or where you're going to integrate a rate function to determine a total value function. Okay, again, remember, integration is like the inverse of differentiation. So differentiation, you start with a total function and you differentiate it to get a rate of change of that function. Integration's the inverse. You start with the rate function and you integrate it to get the total function. So you're going to be looking for keywords in the application problems like rate and total, okay, because they're going to tell you what you've got and what you need to do with it. So the first application we're going to talk about is consumer and producer surplus. This is a concept that was developed about 150 years ago, maybe even longer ago. It's in the 19th century. And it was used to measure the social benefit of public goods like railroads, roads, bridges, things like that. And it was based on the concept of what's called marginal utility, which you may have heard of in economics class. And it's the individual's satisfaction, the consumer's satisfaction with what satisfaction they gain for consuming one more unit of a public good. Okay, remember, marginal is a rate. Okay, so marginal utility is the satisfaction a customer gets from consuming one more of a good. Now, if they've already got a lot of the good, let's say they live somewhere where the roads are great, okay, they're not going to get that much satisfaction from one more unit. However, if you live in a place where the roads aren't good and they're improved, then you get a lot of satisfaction from consuming one more unit of the good. So that's the concept behind this, okay? And again, a lot of you, I'm sure, have taken an economics class and you've seen supply and demand curves, okay? So what I'm showing you here is a pair of curves, okay? This blue curve, and I am apologizing because I realize the colors aren't showing up too great here. This is your supply curve, okay? Basically, the red curve here, okay? And I have the words backwards, so I'll fix that, okay? So here's your demand curve, here's your supply curve. So let me label those. Okay, so here's supply. times demand. Okay, so basically, again, apologize for the color fade out here. Okay, so what the supply curve is showing you is that as more of the product is supplied, and the product here quantity is on your horizontal axis, okay, and here's the price on your vertical axis. Okay, so as more of the quantity, the product is supplied, you can see what's happening to the price. Okay, the price drops. Okay, so basically, when there's plenty of product on the market, the seller can't charge that much for it because there's plenty of it available. Okay, here's the demand curve, the red one, and that shows that as more of the product is demanded down here, okay, the price increases. Okay, so here we've got plenty of product and the price is dropping. Here there's a big demand for the product, so the price is going up. Okay, so again, everybody's comfortable with supply and demand curves, right? I'm going to ask you that. Everybody comfortable with the idea? Okay, so again, you'll notice these two curves cross at some point, okay, in the middle, and that's called the equilibrium point. Okay, and it's usually represented in economics with a little star. So here's the equilibrium quantity. And this is the equilibrium price. Okay, and then basically at that point, okay, the supply and the demand kind of balance out, the price stabilizes, and so does the supply of the product. Okay, everybody good with that? So what I'm showing, and again, I'm hoping the colors show up a little bit better. This is meant to be pink down here, and this is meant to be blue down here. Okay, so let's assume our price and our quantity have stabilized at the equilibrium point. What have we got over here? Okay, this blue area here, all right, remember this line over here is equilibrium price. Okay, that horizontal line is at your equilibrium price. Okay, so basically the blue part that's above the equilibrium price is the amount that your consumers would have been willing to pay above equilibrium price. So this blue area is called a consumer surplus because if, you know, by buying at equilibrium price, this is the money the consumers have saved, right? Because they would have been willing to pay more for the product. Likewise, over here, this pink area, okay, below the equilibrium price is the amount the producer would have been willing to sell at, right, below the equilibrium price. So this is a savings to the producer, okay? So these shaded areas are exact. You can think of it as money in the pocket of the consumer and the producer, okay, because they sold at equilibrium price. Okay, is everybody okay with the idea of the surplus? Okay, make sure that makes sense. Right, so again, I'm trying to explain like the logic behind what we're going to do. Okay, everybody all right with the idea of the surplus? Okay, so in both cases, this blue area here, the consumer's saving money. Here, the producer is saving money. That's why it's called a surplus. Now, let's take the economics hat off for a minute and put the math hat on. Okay, you see here I have two curves, right? I have my demand curve and I have my supply curve. And again, like I said, I've got them colored backwards, sorry. Okay, so basically what you've got going on here is area between two curves. Okay, you've got area between two curves. And again, we know we can find that with an integral, a definite integral. Okay, In this case, with the blue area, we're going to be taking the area between our equilibrium point here, okay, our equilibrium price and the demand curve. And here we're going to be taking the area between the supply curve and the equilibrium price, okay? So that's essentially all we're going to do. We're going to be applying what we know about the definite integral to the concept of finding an area between two curves, okay, to the idea of consumer surplus and producer surplus. So that's really all we're doing. We're applying the integration principle here. Okay, everybody good with that? So let me switch. And again, I promise I'll change the notes to reflect the correct curves and stuff. Okay. All right. So again, consumer surplus, the blue area on the graph, you have to think about what you've got here. Okay, the blue area on this graph, okay, is the difference here. Okay. Again, I think these are the ones that are backwards. Okay, not mine. I think I had them right. Okay, because if you think about it here, okay, when you're supply and demand, you're going to have this relationship. Okay, so let's take a look over here. All right, I want to find the difference between the demand curve and the equilibrium price. Okay, so basically that's going to be here. Okay, is what I've got, and the equilibrium price. Let's take a look at it. All right, here's P star, equilibrium price. Okay, and here's my demand curve. Okay, so I want to find this area. Okay, so if I take a look at my integral, you can see my upper curve is the demand curve. My lower curve is P star, which is just a horizontal line. Okay, so here's what I'm doing. Here's my upper curve minus my lower curve. Okay, so I'm just going to integrate that. And remember, you're integrating across to your equilibrium quantity, which is down here. Remember, this is the point that's Q star, P star. Okay, so you're going from 0 to the equilibrium quantity. Okay, so again, I'm just finding the area under the curve from 0 to Q star, right? And it's, again, P star is on the bottom and the demand curve, D of Q, is on the top. Right? So hopefully that makes sense. You can break this integral into two parts where you're integrating the demand curve first, and then you're subtracting the integral of P star. Okay. The second integral is really easy to evaluate because this is a constant. So all you're going to wind up with is Q multiplying your equilibrium price. Okay. And so you basically get this as your final formula. Oh boy. Hold on. My pencil lost its mind. So you're going to wind up getting this as your expression for consumer surplus, right? So there's a formula for it. It's the integral from 0 to the equilibrium quantity of your demand curve minus the product of equilibrium price times equilibrium quantity. Okay, so here you have the basics. Okay, again, not quite sure why I'm having a problem. Likewise, I've got a producer surplus, which is the pink area on the graph. And again, I'm going to go back to my picture here. You can see there I'm subtracting the supply curve from T0. Okay, so here's my supply curve. Can't get it to right. Let me just close this for a moment, folks, and see if I can get back in. Yeah, I'm having some technical issues today. I'm so sorry. Anyway, we're trying to find this area down here where the supply curve's on the bottom and P star, the equilibrium price, is on the top. Okay, so that gives us this expression, okay, with first we have the upper curve minus the lower curve, okay, and then we break that into two integrals, and you can see they look kind of symmetric. Here you've got the P star, Q star out in front, and then you're subtracting the integration, the area under that supply curve, okay? Here is the summary of it, okay, based on what's in your text, okay? So this just explains what I just did here, okay? Consumer surplus, producer surplus. If you add these together, these numbers, because again, they're definite integrals, they're going to give you numbers, you're going to wind up with something called the total gains from trade, okay? So again, it's not an economics class, but it's important to kind of understand what you've got going on. And again, the problem I'm having over here, by the way, is the actual information here is, you know, a little bit weird as far as the colors are concerned, okay? So again, I apologize for the color problem, right? But anyway, does anybody have any questions about where the integrals came from? Questions about where the integrals came from? Anybody questions about any of it? It's just total, it's the area between two curves. That's all it is. Okay. Okay. Let's talk a little bit about the units of these and pretty much, you know, how to do applications. Okay. So the units are area units. Okay. And if you think about it, okay, you're going to multiply the horizontal units by the vertical units. Okay. So your horizontal units are quantity, okay, of items, and the vertical units are price per item. Okay. So you can think of it here as items times price per item. And again, can't write on my tablet. Okay, I apologize. I'm going to have to figure out a way around this. Okay, so anyway, here, okay, these are going to have items canceling out. So your answer is going to be in money. Okay, it's going to basically be money items. I know my thing is charged because I had it done. Okay, so let's say we have a demand function that looks like this, okay, D of Q, and a supply function that looks like this. Can anybody figure out how we would determine equilibrium quantity and equilibrium price? How do you find equilibrium quantity and equilibrium price? Okay, so I'm showing you example one, and I'm asking you a question about it. Anybody have any ideas? Think about what equilibrium means in terms of supply and demand. Okay, good idea, Benjamin. So we would set these two equations equal to each other, and find the value of Q that makes it true. Okay. Why don't you try that? Okay. I'm trying to work on some technical challenges here. So you try that. You try setting E of Q equal to S of Q to find Q star. Okay, so we're trying to find Q star. Okay, so why don't you work on that? Okay, type done. Finish. We'll take another minute or so. Okay, so what value of Q did you get? I'm seeing a couple of people are done. Yeah, 900. Okay, so again, I'm going to have to try this a little bit differently. Okay, so please bear with me. 900 is right. Did anybody solve for equilibrium price? In order to get equilibrium price, all you have to do is pick either the supply equation or the demand equation and put in your Q value. Okay, so try that and see if you can get the equilibrium price. Okay, meanwhile, I'm going to see if I can try another approach here. Okay, has anybody been able to get a p-value? Okay, so basically we're saying that our equilibrium quantity is 900 and our equilibrium price is $150. Okay, once you have those two values, you're in good shape to find consumer surplus. Okay, so what I'm going to do, folks, is I'm going to go back to the meeting since I am not able to use my iPad, and I'm going to do the old school thing of trying to write on the board that's behind me. Okay, so you have to let me know if you can see what I'm doing. All right, so I'm going to go stop sharing and go back to the meeting. Okay, so again, can everyone see my whiteboard? Okay, again, what I'm going to try to do is to just basically show the active speaker video. Okay, so I can see what I'm writing. Okay, and then again, let me know if anything stops working. I'm going to get my chair out of the way here. All right, so hopefully you'll be able to see the whiteboard. Good and close. All right. Okay, so we had our demand function was 4,500 over the square root of Q. I don't know if that's visible. And it's reversed, isn't it? Can everybody see that? Again, I'm trying to figure out where I can write on this board. All right, everybody seeing that? And then I have the S of Q, okay, which I said was 5 times the square root of Q. All right, and we're setting that equal. Okay, so okay, everybody getting that? All right. Now, in order to simplify this. Okay, I'm going to multiply both sides by the square root of q. Okay, that gets rid of them here and gives me 4,500 times 5, and q times square root of q times square root of q is q. Okay, and then the last thing I'm going to do is divide by 5. Okay, and that gives me 900 equals q. And because we set supply and demand equal, this is q star. Okay, everybody all right with that one? Hey, it's just like being in class, right, with a whiteboard and everything. Okay, please let me know right away if you can't see it or you can't hear it. Okay. So everybody all right with equilibrium quantity? Then I just pick one of these equations that I started with, either the demand or the supply, and I put in 900. I'm going to use this one because it looks easier. Okay, so here I have 5 times the square root of q, and that's 900. Remember, this is going to give me the price. Okay, so this is going to be P equals 5 times 30, okay, which is 150. And so P star is 100. Okay, anybody have questions about how to get equilibrium quantity or equilibrium price? Set the two supply and demand equations equal. First solve for Q star, and then plug it into either equation to get P star. Okay, well, let's figure out what consumer surplus is. Now that we have Q star and P star, we're good to go. All right. Okay, so here's our consumer surplus formula. Okay, it's the integral from 0 to Q star. And again, remember, the demand curve is on top. Okay, so I'll put my demand curve. Okay, that's my demand, right? And then I'm going to subtract P star Q star. Okay, so P star was 150 and Q star was 900. So here's BP, here's P star, Q star. Hey, everybody all right with that part? Okay. And then if I want to actually do the integration, I probably want to rewrite this down in the denominator. What should I rewrite this Q down in the denominator? If I want to rewrite my integral like this, okay, my Q star is 900. Okay, I want 4,500 times Q to some power. What power should I write Q to? What power goes on Q? -1/2, good, because it's in the denominator and it's a square root. Okay, and then I have this product over here, which is just a number. Okay, that's 135,000. Okay, and again, remember this has a DQ on it. All right, this part out here isn't part of the integral. Okay. Right, this is just a constant out here. Okay. If you think about it, they've already integrated that and plugged in the lower bound. Why is it -1/2? Okay, it's -1/2 because you've got a square root in the denominator, right? Square root has a power of 1/2 on it. Remember, the roots have fractional exponents. And the negative sign means it was in the denominator of a fraction, okay? Again, those are two rules of exponents. One is the rule for fractional powers or roots. The other one is negative exponents mean the quantity was in a denominator, right? Okay, any other questions on what I've got so far? Okay, so now we're ready to integrate this part. I'm going to pull the 4,500 through the integration. Okay, because it's just a coefficient. And then I'm going to integrate q to the negative 1/2. So that means I'm going to add a whole 1 to negative 1/2. That's going to give me q to the positive 1/2, right over that. Okay. Everybody all right with that? That's integrating with the power rule. Okay. And then I have the evaluate from 0 to 900. All right, and then don't forget this is out over here. Okay, everybody good with that much? Okay. This divide by 1/2 can be rewritten as 2 times. Okay, so I'm gonna to get rid of this. Again, I have to conserve real estate on the board here. Sorry. All right, so I'm rewriting the divide by 1/2 as multiply by 2. That's just algebra. Okay, the 2 is in the 1/2 is in the denominator because that's the power rule for integrating. Okay, I took this q to the negative 1/2. Okay, and hopefully this is still on the board. Q to the negative 1/2 plus 1 over negative 1/2 plus 1. Okay, and that gives me q to the positive 1/2 over 1/2. Okay, this right here is the power rule for integrating. Okay, you add 1 to the exponent and then you write the result over the new exponent. Okay, that's how come. And then the last step was to rewrite this instead of divide by 1/2, multiply by 2. Multiply by its reciprocal. Okay, so that's where I got the 2 over here. Sorry, I have to go down. All right, so this is 4,500 times 2q to the 1/2. All right, anybody else have questions? I'm trying to stay away from the board so you can see what I'm doing. Okay. So the rest of it is to just evaluate. This 4,500 times 2 is 9,000. Okay, and then I'm just evaluating q to the 1/2, which is the square root of q, at 900. That's my upper bound minus my lower bound minus 135,000. Okay? Everybody all right with that? Okay. Again, 2q is because I'm dividing, if you're asking about this, okay? Remember, dividing by a number is the same as multiplying by its reciprocal. So the reciprocal of 1/2 is 2 over 1. So that's why I'm multiplying by 2. I don't want to keep the complex fraction with fractions in the denominator, so I'm rewriting it. Okay? All righty. So is everybody good with this so far? Again, it's really tough for me to see what's showing on the board. Okay, so I'm going to depend on you guys to let me know if I start writing off the bottom of the board, okay? Looks like it's okay. All right, so if I evaluate this, I'm taking the square root of 900, that's the 30. This is a 0. I'm multiplying these two together, 30 times 9,000 minus 135,000. When I do that, I get 135,000. So this step is just an arithmetic step. Okay, you can do it on a calculator. Okay, so is everybody okay with consumer surplus? Anybody questions about consumer surplus? Okay. So essentially, this is what your consumers save, $135,000 by buying at equilibrium price, because they would have been willing to pay more. Okay, think about the market right before the holidays, like now. Some folks are after a particular thing, maybe for their kid or whatever, and they're willing to pay more than market price because, you know, it's the latest hot thing. So that's kind of where this comes in. All right. If you guys could do me a favor and just type in the chat, okay or not okay, yes or no, just so I know you're still there. Okay, thanks. All right, we're good with this. Anybody have questions? Okay. Producer surplus works pretty much the same way. Just remember, you're finding the difference there between the supply curve on the bottom and the equilibrium price on the top. Okay, so remember that's the below part. Okay, so it's just shifting the two things in the integral. Okay, so I'm going to quickly go through producer surplus. And again, hopefully if you have the notes up in a tab, you'll see what I'm actually doing here. Okay, I can't bring up the notes and project the whiteboard at the same time. Okay, so let's work on that. And I promise I'll fix whatever is wrong with my tech by the time we meet again. So we won't have to do this. Okay, so again, producer surplus is the equilibrium price times quantity. Okay, so let's see if I can get that on the board right now. So here's our equilibrium price and our equilibrium quantity. And then I'm subtracting the integral of the supply curve. And again, that's from 0 to the equilibrium quantity. That's Q star. Okay, again, I'm showing you so you can kind of figure out where I'm getting these numbers from. Okay, and then this part would be our supply equation, which is 5Q to the 1/2. Okay, remember this is a square root, so I'm writing it with the exponent of 1/2. Everybody okay with that much? You see where it's coming from? So this is producer surplus. This is the same number, the 135,000 that I got before. And this time I'm going to pull through the 5 because it's a coefficient. And then I have the integral from 0 to 900, Q to the 1/2, and Q. Okay. And then integrating that, this is a 1/2 already. So I'm going to use the power rule on it. So let me just rewrite everything so you don't lose anything. Okay, so I'm adding 1 to 1/2. That gives me 1.5 or 3/2. And then write that over 3/2. That's the power rule for integration. Okay, and then I'm going to evaluate that from 0 to 900. Okay, remember it's only this piece that gets integrated. Okay, this product of P star times Q star that is not in the integral. Okay, so first I'm going to kind of rewrite this a little to make it easier to work with. Okay, I have 5 times, and again, I'm not going to divide by 3/2. I'm going to have 5 times 2/3. Okay, which gives me 10/3. Q to the 3/2 from 0 to 900. So this is just algebra to simplify it. Okay, what did I do here? I flipped this upside down and made it a multiply, and then I have 5 times 2 is 10 on top, the 3 is on the bottom. Okay, and then the rest is just evaluating. Okay, I evaluated at its upper bound. Okay, so I'll take out the 10/3, and that's 900 to the 3 halves minus 0 to the 3 halves, which is just going to be 0. Okay, and when I put this in my calculator, the whole expression, I get $45,000. Okay, so that's the money your producer saved by selling at equilibrium price. Okay, because they would have been willing to sell at a lower price. Okay, again, the 3 halves, if you have q to the 1 half, hoping you can see this, q to the 1 half, and you want to integrate, you add 1, you write it over the new exponent. Okay, again, think of 1 as 2 halves, so you're adding 1 half plus 2 halves, that's q to the 3 halves over 3 halves. Okay, it's called the power rule for integration. And then I'm just flipping this to get q to the 3 halves multiplied by 2/3. Instead of dividing by 3 halves, I'm multiplying by its reciprocal. Okay? Anybody got any other questions? Okay, with producer surplus? Okay, I'll take a minute for you to put a yes or a no in the chat. Okay, let me know if this is okay. So pretty much all of the problems that you might find in your homework are similar to these, okay? If they don't give you a supply and a demand equation, they may just give you a Q value and just assume that whatever Q value they've given you is your equilibrium quantity, okay? So basically the strategy is the same. If you've got supply and demand, set them equal, find Q star. Okay, if they don't give you 2 equations, okay, then they must give you Q star, okay? All right, they either have to give you Q star or P star and one of the equations, so you can figure out the other one. Okay, does everybody understand the algebra behind this? Okay, the algebra, okay? Again, I know it's a long time since you've done some of this stuff, so please ask if it's not clear, right? The notes I upload will have all of this worked out. Okay, so you don't have to worry that, I can't see what she's doing or I can't, copy it. First of all, I'm making a video of what's on the board. Okay, and secondly, the notes will have it all written out on it. Okay? All right. The second thing I want to talk about is the present value and future value of a continuous income stream. Okay? So basically, let me talk about this for a minute. Okay, there are some businesses where your income flows in pretty much of a continuous rate. Okay, most of the businesses that are like this are kind of, you can think of them as if you've got rents coming in on a continuous basis from a whole bunch of properties. If you've got an oil well or multiple oil wells that are producing continuously, mines where you're constantly getting income from what comes out of the mine. So we're thinking of continuous income stream. Okay, and there's a formula that you might have seen before for amount. I guess I should call it a future value. Okay, so future value of an amount that's compounded continuously. Okay. Okay, so say we have a continuous principal, right? This is what we get on a continuous basis. We're going to multiply that by e to the RT, where R is the rate you can earn on the money, and T is for how long the stream flows, okay? So essentially, if you're, say, making an amount, a P amount of $20,000 a month, okay, or a year rather, you can basically say, what interest rate can you get on that money and for how long, okay? And that will give you the future value of your income stream, okay? Now, the idea of future value is what the money is going to be worth in the future, right? Depending on how much you can earn on it. Present value is what is it worth today? Okay, is everybody comfortable with future and present value? Okay, everybody good with future and present value? Okay. So essentially what we're saying is as long as we can model the flow of income from your investment, whether it's a well or a mine or whatever, with an equation, we can figure out what it's worth in the future. This is important for a whole bunch of reasons. Okay, you're going to want to know that if you plan to sell your investment today. You want to know what would it be worth in the future so you can set the price on it correctly. Another reason you might want to know its future value is for insurance purposes. Okay, you would want to know how much it's worth to insure. Okay, so let's talk about continuous income streams. All right, so again, I'm assuming people have seen an equation like that for earning interest on a continual basis. But here's a continuous income stream. Okay, and basically, let's say it can earn an interest rate of R. Okay, and you have a compounded continuously situation. I'm sure that's not spelled right, but you know what I mean. Okay, and you want to be interested in a term of T years. Okay, so your present value. Okay, so remember, this is an income stream going into the future, and you want to find what is it worth today. You integrate from 0 to T. Okay, your F of T is your rate, your income rate. Okay, so remember, to get a total, you take a rate function and you integrate it. Okay, and then here's the e to the minus RT. Okay, kind of reverse the idea. All right, so this is a formula for finding the present value of a continuous income stream, provided you have the rate. Okay, we're going to plug in the rate of the income generation. There's two rates here. There's the equation that tells you the rate the income's coming in, and then there's the interest rate, which is the current market rate you can earn on your money. Okay, they have to give you these two things. Okay, and then T is for how long. So the variable of integration here is time. Okay, once you have that, your future value, you don't need calculus for. You can just say, take a P here, present value, and multiply it by e to the RT. Okay, so that was that formula I showed you before, where I'm using PV instead of P. Okay, so this is no calculus. Okay, but to be honest, if you're working with these types of problems, and you have the rate at which you're generating income. This is the rate your income stream is flowing. Okay, the first thing you're going to have to do is find the present value of it. And then if you want to know what it would be worth in the future, you're essentially saying, if I took the money today that this is worth today and invested it, what would it be worth 2 years from now? Okay, so you need to find this first, then that. Okay, let me stop right now and ask you if you've got questions. Questions? Okay, again, there's a lot of theory here because, we're talking about a business situation. Okay. Now I have 5 examples. I think I'm only going to show you 2 of them, okay, because they're the 2 crucial ones. But again, like I said, I'll upload my notes with all of the examples here. But again, I want to kind of show you the strategy. Okay. Is everybody good with this? All right, so I'm going to be using these 2 formulas, the PV and the FV. Okay, it's in the notes and it's also in your reading. Okay, so let's say I have an opportunity, a business opportunity, and it is to buy a business that generates income at the rate of $75,000 a year. Okay. So that's the rate at which this business generates income. Also, I know that I can earn about 2.8% on money. Okay. And I'm assuming if I lock it in for the next 8 years. Okay. In general, you get higher rates if you lock up your money, right? So they're telling me they want me to pay $630,000 for this business. Okay, and my question is it worth it? In other words, if I hold on to this business for 8 years, will I at least break even? Okay, based on the income stream that's generated. Okay, so what I want to do is I want to find the present value of this income stream. Okay, and then I want to see if it's more or less than $630,000. If the income stream generates less than $630,000, I'm not going to buy the business. It's not worth it. If it generates more than that, then yeah, I'll make a profit. Everybody understand the idea? Everybody understand the idea? Okay. Alrighty. So this is an actual rate. See the per? Okay, so this is my rate function, f of t. Okay, so f of t is simply the constant 75,000. Okay, it's a rate, it's per year. That's why I'm going to put a dt on it. Okay, so here's my present value formula. Okay, it's the integral from 0 to t, and in this example, t is 8. And I'm going to put my rate function times e to the minus rt. So my rate function is 75,000. Okay, so it's a constant rate of 75,000 a year. And then I have e to the minus my interest rate. 2.8 is 0.28. And again, t is in there as a variable. Okay, little t and big T are kind of different. Okay, this little t is your variable. Okay, and there's your rate. Everybody comfortable with that? Okay. This 75,000 is a coefficient, so I can pull it out of the integration. Okay, and then I'm integrating e to the negative 0.028t. If you remember, when you differentiated this using the chain rule, you multiply this exponential by the derivative up here of the exponent, by this coefficient. Since we're integrating, okay, here's the way you do it. And again, this is in your cheat sheet, the notes for integration. You divide it by your derivative, okay? If you took the derivative of this exponent, you'd get negative 0.028, okay? Since we're integrating, we're going to divide by that. That's just rules for integrating an exponential. Okay, and then I'm evaluating that from 0 to 8. Okay. Just a hint, I would kind of leave this division, okay, again, alone. I put this out here. Okay, you can simplify it, but you know what? If you do, you're going to wind up with rounding errors. Okay, so leave it like that. And then just substitute in 0 to 8 times 8 minus e times negative 0 to 8 times 0. Okay, remember with exponentials, you can't throw away this second half because this is going to be e to the 0, and that's a 1. Okay, everybody all right with that part? Okay, any questions at all on what I did? I pulled this from the denominator here out here. You can think of this as like 1 over negative 0.028 times e, and so I pulled it out. This is something I can evaluate on a calculator. When I did that, I got 537,548 and 75 cents. This is the present value of the income stream generated by this business over 8 years. So you tell me, is the purchase price of $630,000 worth it? What do you think? Based on what I have here, is the price worth it? Okay, Tuyen says we shouldn't buy it. Anybody else have an opinion? Again, the purchase price, they want $630,000 from me today, and I know this business is going to generate $537,500 over 8 years. Okay, this number is less than the purchase price, so no, I should not buy the business. Okay, the business isn't productive enough. Okay, so again, my response would also be no. Does anybody have questions about this type of example? Anybody? Questions? Okay. Now we have a kind of another example that we can do. All right. Now remember, you can do any kind of integration at all. Some of these will involve simple integration like this, where you're just using either the power rule or simple exponential integration. Some of them involve integration by parts. Okay. So again, I think rather than doing the one on future value, okay, remember, if they ask you for the future value of an income stream, first you find the present value, then you just use the future value formula, which doesn't involve calculus. Okay, I'm going to skip that example And I'm going to work on the last example that I was going to show you, which kind of talks, it has a more of a complicated integration. Okay, so let me do that. I'm assuming, again, no problems with this. Okay, again, what's important with this example is making sure you can interpret what this answer is telling you. This answer is saying, don't buy the business. If I got $837, I'd say, oh yeah, I'm going to buy the business. It's worth it. Okay, so let's do one more example. And it's a similar type of example in that I'm trying to determine whether something is worth the purchase price. So in this case, I'm interested in buying some machinery for my manufacturing business. And they're telling me that this machine will generate a continuous income stream, okay, whose rate in the teeth year of operation will be this. Okay, it's 15 minus 2t, and that's in millions of dollars. Okay, everybody can see the whole thing? Okay. So we're assuming the lifetime of the machine is about 7 years. Okay. And the money can be invested. If I took the money and invested it today at 8%, okay, I don't know of any investment other than stocks that might pay at that rate. Okay, but let's say we can get 8% and it's compounded continuously. Okay. And again, we want to find the fair market price of the machine. Okay, which they're going to assume is the break-even point. Okay, in other words, if you can earn the same amount of money, right? If the future value of your machine is X thousand or X million dollars, okay, that's the fair market price because that's the present value of this income stream. Okay, so we're going to find the present value of an integral from 0 to 7, where this is the lifetime of the machine. Okay, and then here's my rate, 15 minus 2t. Okay, and this gets multiplied by e to the minus 0.08t. Okay, everybody see this integral? Okay, now here's my question to you, okay, is how would you do the integral? How would you integrate? Take a look at this. Okay, so I'm asking for feedback. Please let me know what you think. Anybody have any ideas, strategies? Okay, this is important. You've got to be able to decide how to integrate. I'm seeing a product of functions, okay? And I'm not seeing anything that looks like the derivative of anything else, right? This 15 minus 2t has the wrong power of t to be the derivative of this exponent, okay? And the derivative of this is going to be a constant, not something with e. So these are two unrelated functions. Two unrelated functions. How do you integrate two unrelated functions, folks? Do you use substitution? Do you use by parts? Anybody know? Yeah, okay. Tuyen's got it. It's by parts. Okay, you need to use by parts. Okay. And again, if you think about it, okay, you've got an algebraic function and an exponential function. There's no log function in here. So if you don't have a log function, then you're going to let your algebraic function be u and the other function be dv. Okay? Remember I showed you how to do this with a table. Okay, so again, hopefully I can tip my computer and you can see the table. So I'm going to differentiate u and I'm going to integrate dv. Everybody all right with that? Okay, does everybody understand why we chose by parts? Okay, you choose by parts when you've got a product of two unrelated functions. Okay, and then you choose the u function to differentiate by looking at it and saying, is it log? I haven't got a log. Is it algebraic? That's u. Okay, if I had a log function, then that would be my u. Okay, so I'm going to differentiate u. I'm going to integrate this. Okay, so again, it's important to remember what you're doing. All right, and again, I want to try to show you the whole thing. Okay, so when I differentiate this, the 15 gives me a 0. This is going to give me -2. All right, and then differentiating it again, it's a constant, so I get a 0. Remember, once you get a 0 in the differentiate column, that's when you stop the process. Okay, and then over here, if I integrate, I'm going to keep accumulating -0.08 in the denominator. Okay, so that's the integration the first time. Okay, when I integrate it a second time, I'm going to get another -0.08 multiplying what I've already got down here in the denominator. So the next one's going to be e to the -0.08t. Negative times negative is positive. So 0.006. Okay, and that's just, again, using the rules for integrating an exponential. Okay, since I got to 0 here, I actually can show these diagonal arrows. Okay, everybody good so far? And then all I'm going to do is I'm going to, again, put the positive and negative signs on them. Okay, so over here, I've got a positive and a negative. Okay, and then I just pull things out, and again, I have products. Okay, so I have 50 minus 2t times this product, e to the -0 times 0.28 t. Wow, 0.8. Okay, that's the first product. Okay, the second product has a negative sign on it, but notice it starts with a -2. Okay, so again, you can put the -2 in here if you want. And then you're multiplying that by this other half of the product. Okay, everybody good with that? So I have two terms in my answer here. Okay, and then I evaluate it from 0 to 7. Okay, this is a little tricky because, again, this has two terms in it. You're going to plug in the 7 as the upper bound, and then you're going to plug in the 0 as the lower bound. It's strictly a calculator operation. Okay, so I got a present value. Okay, the upper bound gave me and the lower bound gave me. Okay, so my present value is 46.36. And remember, everything was in millions of dollars. Remember that this income stream was in millions. So this is in millions. Okay. So again, a fair market price for this machine is $46.36 million. Okay. So again, I realize I'm not showing you every last blessed step here. Okay, I will make sure to show that to you in my notes. Okay, but basically what I wanted to show you is sometimes you'll need to do an integration by parts. And then when you get the answer, which is just this sum and difference of products from the table, you just evaluate it at the upper bound minus the lower bound, and then do the subtraction. Okay, anybody got questions on any of these? These are all pretty straightforward applications of formulas. Questions? Anybody got questions at all? Again, I'm just stopping for a check. Questions? So again, the formulas for all of these are in your text. They're also in the notes, and I'll be uploading those again with this video. All right, and I promise that I will have my technology working when we meet again next week. But if you guys don't have any questions, that's pretty much all I have for today. Okay, I'm going to stop my recorder.